So very good morning, all of you. So in the last class, I have explained about the energy coupling and its definition and different types of the energy coupling. That is nothing but the probes, okay, loops and the slots. Okay, and in this class, I am going to explain about the modes of the propagation. Especially it is modes of the operation of the waveguides here. Okay, so in this class we are going to study the mode of the propagation in the waveguide, its modes here, and and also we'll see the modes classification and the operation of the T and the TM modes in the rectangular waveguide, and also we see the field pattern in the TE and the TE modes, especially in the rectangular waveguide and also in the circular waveguide. Okay, and also we'll see the dominant mode representation of the rectangular as well as the circular waveguides. Okay, so if you take the mode of the propagation in the waveguide, okay, it is to be depends mainly on it is dependent mainly on the four factors. It is one is the operating wavelength of the waveguide. Okay, so it is what is the length of the waveguide is available. It is going to define that parameter, and the one more is the polarization. So under what phase it is going to move the signal, and one more is the shape. Is it in the rectangular pattern or is it in the circular pattern or is it in the rigid pattern, etc., is also going to matter. And it's a size. It is what is the size of that waveguide. Okay, and so all these four parameters are important in order to measure the mode of the propagation in the waveguide. Okay, so the waveguide propagation mode is to be depend on the operating wavelength of the waveguide and its polarization of the waveguide and the shape of the waveguide and the size of the waveguide. So each mode is characterized by a cutoff frequency that is below which the mode cannot exist in the waveguide. So each of the parameter is going to play the very important role. According to that only, it is going to able to accept the certain it is frequency range. And if it is below that one means it is not going to accept the signal into the waveguide there. Okay, this is about the waveguide mode propagation dependent. And if you take the modes in the waveguides, its classification, it is to be classified into of the four modes. One is of the TEM mode. It is a transverse electromagnetic. It is to be dependent on the E lines and the H lines. It is dependent on the what electric field as well as on the magnetic field. So for that purpose, it is called as of the TEM mode. And another one is it is TE mode. It's nothing but it is transverse electric mode. It is dependent only on the electric lines. And if you take the TM mode, it is also called as of the transfer magnetic mode. It is dependent on the H lines. It is magnetic field. And another one is the hybrid mode. It is entirely dependent on the electric as well as the magnetic. So the TE mode means it is to be dependent on the voltage signal, and or the TM mode it is dependent on the current signal. It is one more alternative way to remember. So if you take the modes in the waveguide, it is to be classified into the main four types. One is of the TEM mode, one more is TE mode, one more is TM mode, and another one is the hybrid mode. Okay, so if you see the definition of all these four modes, initially if you take the transverse electric modes, so it is also called as of the H modes here. It is because only the magnetic field is along the direction of the propagation. So H is the conventional symbol for the magnetic field, and it is no electric field in the direction of the propagation. So that is E field is not along the direction of the propagation of the signal, and the electric field is in the transverse plane, that is it is perpendicular to the length of the waveguide, And if the signal is going to flow in this pattern, it is called as of the TE mode. Okay, if you want means you can see in the diagrammatically, this is the representation of the TE mode. So that you can able to see only the left side. So if you see all the electric field, E lines, okay, the indication of the lines with the blue color is the what? Electric line. It is going to be perpendicular. Okay, so I have mentioned there is electric field in the transverse plane is perpendicular to the length of the waveguide. If you take this is the length of the waveguide, and if you take the electric field is going to be perpendicular to the length of the waveguide. Observe that all the blue color lines is going to be perpendicular, so that is indicating the electric field. And if you take the magnetic field, it is going to form the loop here inside, and it is along the direction of the propagation. So for that purpose it has been mentioned the H modes. So the magnetic field is along the direction of the propagation. It is and it is no electric field is in the direction of the propagation. You can able to see along the direction of the propagation, the electric field is not available. Only the magnetic field is along the direction of the propagation. So the arrangement itself is called as of the TE mode. Okay. So important point to be remembered is, so the magnetic field is along the direction of the propagation, and the electric field is perpendicular to the length of the waveguide itself is called as of the TE mode. And if you take the TM mode is exactly opposite. In this case, the magnetic field is along the direction of the propagation. But in this case, you can observe the electric field. It is E lines is along the direction of the propagation. If you take the magnetic field is in the reverse plane, and it is perpendicular to the length of the waveguide. So that you can see in the diagram here, see, you can observe or the indication of the blue color I said, it is used to represent the E field. It is an electric field. It is going to be along the direction of the propagation here. This is an half wave and this is another half wave. And if you see the magnetic field, it is going to be the perpendicular, but in this case it is along the transverse plane, but in this case it is along the reverse plane here. It is along the reverse plane. And so it is going to be perpendicular to the direction of the propagation. Indication of the lines with the red color, it is exactly perpendicular to the horizontal plane here. So it is going to be perpendicular to the length of the propagation here. And if the arrangement of the signal, that is E field and what the magnetic field in this order, it is called as the TM mode. Okay, so the electric field is along the direction of the propagation, and if you take the magnetic field in the reverse plane is perpendicular to the length of the waveguide. And in this case, there is no magnetic field is in the direction of the propagation. Okay, so that you can observe the differences now. In the TE mode, the electric field is perpendicular. In the TM mode, so the magnetic field is going to be the perpendicular. In the TE mode, so the magnetic field is along the length of the propagation indicated with the red color here, and in the TM mode, so the magnetic field it is going to be in the perpendicular, it is indicated with the red color here. This is about the TE mode and the TM modes in the rectangular waveguide. And after that, if you take the TEM mode, it is neither the electric, it is nor the magnetic field are in the direction of the propagation. That means that E and the H, it is electric field and the magnetic field are perpendicular to each other. So that if you take the representation of the TEM mode, so that you can see, observe here. So the TEM mode, so the electric field indicated with the red color here, okay, it is going to be exactly perpendicular to the magnetic field. You can able to see the magnetic field indicated with the blue color. And if the signal propagation takes place in this order, so that you can able to see in the another way also, indicated with the blue color as the magnetic field and the indication of the red color as the what electric field, and if it is going to be perpendicular to each other, it is itself is called as the TEM mode. It is a transverse electric magnetic mode. Okay, so it is both electric and the magnetic field are perpendicular to each other. It is not along the direction of the propagation. It is perpendicular to the direction of the propagation. That is itself is called as of the TEM mode. And in this case, the both electric and the magnetic field is used at a time. At a time, it has been used here. Okay. And if you take the one more, it is an hybrid mode. In the hybrid mode, it is going to make use of the non-zero electric and the magnetic fields in the direction of the propagation. It is very difficult to imagine also. Okay, this is all about the different modes of the it is waveguide. One is the TE mode, in which the electric field is it is going to be perpendicular to the length of the waveguide, and the magnetic field is along the direction of the propagation. And if you take the TM mode, in which the magnetic field is going to be perpendicular to the length of the waveguide. If you take the electric field, it is along the direction of the propagation. And if you take the TEM mode, yes, so the electric field and the magnetic field are perpendicular to each other. It is neither the electric field nor the magnetic field are in the direction of the propagation. And in the hybrid mode, it is going to make use of the non-zero electric and the magnetic field in the direction of the propagation here. Okay, this is all about the four modes of the propagation of the waveguides here. Okay, and after that, if you take the field pattern in the rectangular waveguide, suppose consider that it. So if you take the field pattern, especially the rectangular waveguide, it is going to support the TE mode as well as the TM mode. So in the rectangular waveguide, so the rectangular mode numbers is to be designated by the two, so there is suffix numbers attached to the mode type. It is such as TEMN or the TMMN. M and the N is going to represent the field pattern. So the field pattern. Okay. So what the indication of the M is? It's nothing but the indication of the A1, and the indication of the N is indication of the B1. So how many it is the number of the half cycles or the full cycles, or it is 1.5 cycles is going to be represented. It is to be indicated with the M and the N here. So in this case, where M is the number of the half wave pattern across the width of the waveguide, it is applicable only for the rectangular, and for the circular it is going to differ again. Okay, I will explain that. So if you indicate as of the TEMN, means in this case the value of the M is the indicating the number of the half wave pattern. So how many number of the half cycles it is consisting in the A wall. In the A wall, it is going to represent the what? The alphabet M. So if it is consisting of only a single half wave, the value of the M is equal to 1. If it is consisting of the two half wave, the value of the M is equal to 2. In the same way, if it is consisting of the four half wave, the value of the M is equal to 4 in that way. And what the indication of the N? So the N is the number of the half wave patterns across the height B of the waveguide. You can able to see the height B. How many number of the half wave patterns is available across the height? If it is having the 0 half waves, its value is equal to 0. And if it is having the 1 half wave, its value is equal to 1. And if it's having the 2 half waves, its value is equal to 2 here. So I will consider it is one example here. In this case, suppose consider in order to represent the TE10 in the rectangular waveguide. So this is the representation of the TE10. It is consisting of the single half wave pattern. So the single half wave pattern, it is technically represented as in this way. It is consisting of a single arrow along the one direction. It is indicating for the A, and if you draw the signal, it is going to indicate the signal as in this way here. a single half wave. And if you take along the vertical direction, the B, it's not having any of the signal. So it is equal to 0. So the first subscript is 1 here. Since there is only one half wave pattern across the A dimension, only single half wave is present, which is indicating for the first diagram here. So, the value of the A is equal to 1 here, the M. And as there is no E patterns across the B dimension, you can able to see it is no half wave pattern is available. So it's what the second subscript is equal to 0. So the complete mode, it is a description itself is called as of the dominant mode in this case, and it is to be represented as of the TE10. So the TE indicating it is transverse electric mode, and in which the one indicating it is the value of the M, and it is consisting of the single half wave pattern along the, it is the wall A, along the wall A. And what the 0 indicating, it is of the 0 along the wall B. Along the wall B, it is consisting of the 0 half wave. This is about the rectangular waveguide and its a field representation. And if you take the dominant mode, it is what actually the dominant mode. So the mode with the lowest cutoff frequency of all the modes is called the dominant mode. So it should have the least cutoff frequency, and it is itself is called as of the dominant mode. It is between the cutoff and the highest mode. This is the only mode it is possible to transmit, which is why it is called as the dominant mode. Okay, if it is having the lowest cutoff frequency and it is the only which can able to transmit very clearly, so it is called as of the dominant mode. In the rectangular waveguide, TE10 mode is the dominant mode, so that a single half wave pattern at the wall A and the 0 half wave pattern at the wall B is called as of the TE is 10 mode. That is itself is called as the dominant mode. I have explained that example only here. So if the pattern is to be represented as in this way and or in this way, that is itself is called as of the dominant mode. And you can able to see TE20, it is consisting of the two half waves. It's not the dominant mode. And if you take as of the TE30, it is consisting of the three half waves. It is one positive cycle and one negative cycle and another positive cycle. It is consisting of the three. So it is also not the dominant mode. So the dominant mode is only the TE10. So as per this, it is consisting of the lowest cutoff frequency here. And so this is able to generating the spurious modes. And if you take the next highest cutoff mode, which are the TE20 at exactly twice the TE10 mode, obviously in the TE10 mode it is consisting of the single half cycle. In the TE20 mode it is consisting of the two half cycles. It is two half wave pattern. So it is exactly twice that of the TE10 mode or TE01 mode, which is also the twice in the waveguide, which is commonly used an aspect ratio of the 2:1 here. Okay, and if you take the lowest cutoff of the TM mode is TM11, which is the times dominant mode in the 2:1 waveguide. If we want to represent the TM mode, it is under the transverse magnetic mode. T11 is acting as the dominant mode. Okay, so I will explain that in the later. And if you take the circular waveguide representation of the field, if you take the field patterns in the circular waveguide, it is also to be represented in the TE mode and also in the TM mode. And its representation also indicated as of the TEMN or the TMMN. MN is acting as the subscripts. But in this case, the value of the M is the number of the full wave patterns along the circumference, and N is the number of the half wave patterns along the diameter. So if it is going to complete along this one circle around the, it is circular waveguide, that is itself is going to represent the value of the M here. And the value of the N, it is going to form the diameter here, one diameter. That is itself is going to form the what, the value of the N. But in case of the rectangular waveguides, what's that? It is going to indicate the number of the half wave pattern. But in this case, it is going to represent the circumference and the diameter. What the value of the m is indicating the existing portion of the circumference, and what the n indicating the existing portion of the diameter. Suppose consider that, so that I have considered one example here in this pattern, so that you can able to see it is going to be started from this end, and it is going to form, it is one complete circle along the circumference. So this is the waveguide, and in this you can able to see this one circular pattern. So the what the value of the m is equal to 1 here. And if you take the diameter, it is to be represented only with the single diameter of the single line. So this is also equal to 1 in this case. So this is going to indicate as of the TE11. Okay, this is an example of the circular waveguide. And if you take this as the dominant, so once again the same thing, what the dominant mode I said, if it's having the lowest cutoff frequency, that is itself is called as the dominant mode in the rectangular waveguide. In the circular waveguide also it is going to same thing here. So the mode it is with the lowest cutoff frequency of all the modes is called as the dominant mode. So it is between the cutoff and the next highest mode is the only mode it is possible to transmit. So for that purpose itself it is called as the dominant mode. And in the circular waveguide the dominant mode is TE11. So the next highest mode is TM01. I said that in the rectangular waveguide, so the dominant mode is TE, it is 10 or TE01. But in case of the circular waveguide, the dominant mode is the TE11. And in this case also, the range over which the dominant mode is guaranteed to be spurious mode free is less than in the rectangular waveguide. So the ratio highest to lowest frequency is approximately 1:3 in the circular waveguide if it is compared to the rectangular as of the 2:0. Okay, this is about the dominant mode in the circular waveguide. Okay, and I'm going to show you the sample. So you have understood all the concept here. Okay, it is what the mode. It is what is this? Mode of the propagation in the waveguide, and it is what it is to be dependent on. Okay, on operating length, polarization, shape, and size of the waveguide. Okay, and it is what are the modes here? This TEM mode, TE mode, TM mode, and another one is the hybrid mode. And what's about the TE mode, in which the electric field is perpendicular to the waveguide, and the magnetic field is along the direction of propagation. In the TM mode, it is opposite to the TE, in which the magnetic field is perpendicular to the length of waveguide, and the electric field is along the direction of the propagation. And under the TEM mode, it is going to perpendicular to each other. And under the hybrid mode, it is going to make use of the non-zero electric and the magnetic in the direction of the propagation. And it is to be represented here. The indication of the blue lines is going to be the electric field. It is going to be perpendicular here, and the indication of the red color is of the magnetic field. It is along the direction of the propagation here. And it is the TE mode, and if you take for the TM mode, it is going to be what the red color indicating the magnetic field. It is going to be perpendicular. It is all in the reverse plane. And if you take the electric field, it is going to be along the direction of the propagation here. Okay, and if you take the TEM mode here, okay, if you take the TEM mode here, it is going to perpendicular to each other. And in the same way, if you take for the field pattern, it is to be represented as of the TEMN. So MN subscript is indicating the half wave patterns available either at the A wall or at the B wall. The half wave patterns at the A wall is represented by the M, and the half wave patterns represented at the B indicating the N here. And it's one example has been shown for the TE10. And what this TE10 itself is acting as of the dominant mode. It is having the lowest cutoff frequency here. In the same way, if you take the circular waveguide in this the representation TEMN pattern, the indication of the M is indicating the circumference of the this circular waveguide, and the indication of the N is the diameter of the the waveguide. And its example is also shown. It is for TE11, and it is itself is acting as of the dominant mode here, which is of the lowest cutoff frequency. Okay, and all this is about the it is propagation of the waveguides. And if you take the sample questions on this one, means he may ask you to describe the mode of the propagation in the waveguide, or he may ask you to classify the modes of the propagation in the waveguide. Okay, he may ask you to draw and explain the TE and the TM modes in the rectangular it is waveguide. He may ask you to explain the field pattern. Okay, it is TEMN and TMN pattern. And he may ask you to describe the rectangular waveguide with the mode representation, and also for the circular waveguide. And he may ask you to explain the dominant mode in the rectangular waveguide or in the circular waveguide. All these are the possible questions which is concerned for the today's class here. Okay, and in the next class we are going to study about the microwave semiconductor devices. Okay, thank you very much.